This extra meeting will be about defining a class. Okay, and let's summarize what that means. Okay, what means defining a class in C++? What means defining a class in any of these OOP languages? So the first thing is to define attributes. Okay, because their purpose is to store data, right? And remember, at least one of the attributes will be dynamic, and that was the discussion from yesterday. Okay, what else? We have the special methods, right? So let's say define special methods. Special methods, which are, in order to create something, we need a constructor, right? And here you have default and with params, okay? So this is class of special methods. Okay. Then we have what? We have the copy constructor, which is also a constructor, but we know it's used in let's say in strange or not strange, in special cases. So the conclusion was you generally need it, right? The copy constructor. So it's not something you want to forget. Okay. Now you have seen that in Java, a copy constructor is different. Okay. You can have the concept, but it's not so important as in C++ because in Java, everything it's a pointer. So you don't have objects by value. So that's why in Java, you don't have a copy constructor or is not needed. You can define one, but like comparing with C++, in C++ it's mandatory. In Java, sometimes you may want to have one, but sometimes. What else do we have here? The destructor. Again, in C# and Java, you have seen that there is no need, or there is a need for destructor, but it's more a logic destructor. So it's the finalize a method or something similar, but it's not so as important as in C++ because in C# and Java, you don't create memory leaks so easy, right? You have garbage collector. Okay, but in here we need it. Okay, so you have constructor, copy, constructor, destructor, okay? And I will leave this for tomorrow will be the last meeting, extra meeting on operators. But let's say you also need, and we know that sometimes you need a equals operator. So I will include it here, but I will discuss it tomorrow. Okay, so maybe, let's see, I missed something. No, constructor, copy, constructor, destructor. Okay, so these are special methods. Other than that, what do we need to define? Remember encapsulation, which means we need to define everything private. So what do we need? We need to define a public interface for reading and or writing private or protected. This means encapsulation, if you remember, attributes. Okay, because based on encapsulation, you need to define them private or protected. Remember the difference, protected is for inheritance. And the conclusion of the last courses in the semester was that in many cases, we can go by default for protected because in that way, later we can extend the class. Okay, but in the first 7 weeks, we knew only about private. Okay, so both are okay because both means encapsulation in a form of, in some form. Okay, so what is a public interface for reading and writing? This is the list of those methods, which we know them are called getters and setters, right? Okay, now this is something you did in Java and in .NET. I hope you have seen that they have a different way to be implemented, which is more easy, and they are called properties. But generally, they are getters and setters, right? So property in C#, it's a pair of a get and a set. So, but you write less code, for example, okay? So getters and setters. Okay, okay. And what else? Other methods, other methods. Okay, like processing data, computing an average, whatever. So these are the stuff that we can write in a class. And here at define attributes, let's see what are the details. So here we need to be able to define different attributes with different types. Okay. And then how to handle const and static attributes. Okay. And remember, static attributes are not part of an object. They are like class level variables. That was the difference. And here for methods, we have static and class member methods, because we can also have static methods. Okay, so this is the stuff that we need to be able to do when we say we define a class. Okay, these are the, let's say, minimum requirements, but here we are actually cover everything. So let's define a class. Okay, so let's say class, let's say faculty. Okay. Okay. Now remember, we are using mixed camel case, and you use that in Java, which means we use camel case for class names, which means we start with caps, and for attributes we use lower camel case. That's why it's called mixed camel case, because you have either uppercase and lowercase for different stuff. But this is specific to Java, and I think now you have more experience because you did that the last semester. And in C#, I think maybe used, but C#, it's more focused on camel case rather than mixed camel case. Okay, so let's say we have a faculty. So let's define different attributes, okay? Just to make sure we are on the same page, okay? So what means different types? Okay, so let's start with basic ones. So for example, you can have a char, like, so this is a number, a short number or a letter. Let's say it's the symbol of the faculty, okay? A single char or a code. Let's say it's a code. Okay, what else? We can have an integer, right? So this could be an ID. Okay, we can have a boolean. Okay, a bool. And here we can have what is private. It's a private faculty, or it's a state faculty, like essays. It's a state university. Okay, then a number. So let's say float number of students. Okay, but that will be more appropriate for an integer, because float, yeah, number of students are integer value. You can't have 2.3 students. So let's say average fee or average tax. Okay, because everybody talks about taxes right now. Okay, so here let's put number of students. Okay, then we need a dynamic something. Okay, so remember we talked yesterday. I will just enumerate them here. So you can have this, like char asterisk name of the faculty. You can have this string, and here what can you have here? In the faculty, you can have bachelor programs, right? So you can have the name of the bachelor programs, like we have statistics, informatics in English, cybernetics, okay? And remember, when you have an array, you need to know how many values there are there, okay? So number of programs, okay? So these two are related. And if we go for a dynamic array of numbers, we can have something like a number of students per year. Okay, so in this way, you know how many students are in the first year, the second, and the third, and supplementary, and you can go even further. So here I need another variable like number of years. Okay, just to know how many, because I can include also master to be, we can consider master is the fourth year, and so on. Okay, so what do we have here? We have different data types, primitive data types, but here I have the dynamic ones, okay? And we covered this yesterday. How do we define them, init them, and so on. And let's not forget about something you used. You maybe use it in Java and C# because it's useful, and that's the enum, okay? And remember, for enum, I generally I see less this error like other years, which is a good thing. It means that people uh, uh, got it. So when you define an enum, don't define it inside the class, because you need this enum also to define methods here in main or variables. So don't define it inside the class. Okay, so here I will say enum. What can I say? Something like an enumeration about a faculty. Yeah, let's say faculty type. Okay, and remember, when we define enums, we use caps. Okay, this was the, and again, this is the naming convention in other languages. So what can I say here? Faculty type. Let's say faculty domain. Okay, so let's say we are economics. Okay, we can be computer science. Okay, we can be mathematics, etc. Okay, so this is the faculty domain. For example, we are in the economics field. Okay, so now you have this enum, and remember I showed you the difference during the semester between writing enum or enum class, and they are both okay. So you can use enum class or just enum. Now enum is from C, okay, and these are like numbers. So this is 0, you see, this is 1, this is 2. And remember, we can change them. So for example, if I want to make this 20, you say 20, and now this is 20, this is 21, okay? So I'll not dive that. And when you say enum class, there is no difference here. The difference is here when you use it, and here. Remember that in C, because these are numbers, you can actually say faculty domain if you have a variable equals 20, which is computer science. But this is very misleading if you don't know what 20 means. So in C++, they said, hey, let's make the enum symbols to force the developer to actually use computer science and economics and mathematics. And this is what you do when you say class, okay? We talked about this. So both versions are okay. Okay, so if either you use enum like in C or you use the new approach, the only difference is that in the new approach will force you to use every time computer science, which it's recommended also to use when you have a simple enum. Okay, so both are okay. And now here, let's define a faculty domain. So faculty domain, domain. Okay, so these are the attributes, okay? Different attributes. So what do you do? So this is first step. You define different attributes, okay? We will add a const and a static. But what do you do with this? Remember what I told you. And now in Java and C#, this is not mandatory because you get good values, default values. But here, always set your defaults, okay? Don't forget to do that, because otherwise, remember, you get 0xCCC, all those strange values, okay? False. Here 0. So always set your defaults, and especially for pointers, set null. Okay, so don't forget to do that. Will help you avoid errors and losing time. Okay, make this a rule, a very important rule. Okay, and here for domain, let's say I want to use something. Let's add here other. Okay, so here I will say faculty domain. Remember, in Java and C# you have dot, but not in C++. Here you have two dots, two dots. So here I will say other. Okay, so in this way I initialize domain with other. Okay, this one being the last. And let's add a const and a static. So for example, anything can be a constant. So let's say I can say const this doesn't make sense because it can change in the future, but I just want to show it to you. So const string address, okay, and also can be a const int. I have an ID here that will be a good one, but let's define another one. So let's say const int country ID. Okay, let's say this is a unique ID in the country, so it's unique. Okay, so these are constants. So anything can be a constant, and static the same. So static, let's say you can't have, you can't surpass, each faculty has a maximum number of students that it can handle. So let's say this is that value. Okay, so these are the statics. And again, you can have any static here. You can continue this. Okay, so with this, let's say this is a class which covers any combination of values, okay, that you need to be able to handle. If you, I don't know, still have any questions, so if still it's not clear what.
Can we initialize the bool value with 0 instead of false?
Yeah, we talked about this, but it's not right. You know why it's right? Because what are the values for Boolean in Java, C#, any other language? True or false, right? What are those values in C and C++? True and false. But why can you say 0? Because they made this and all the other languages changed this. So with the exception of C and C++, all the other OOP languages, Python including, they don't allow you to put a number here. But in C and C++, when they define it for the first time, they said, hey, let's also make this equivalent. Any value which is not 0, it's true, is considered to be true, and any value which and 0 is considered false. And later, they realized this is bad. It's not clean, will create confusion, and so on. So that's why all the other languages which follow C++, they remove the rule. So let's not waste our time learning something which we use only here and which in the end it's considered bad, a bad practice. Okay, so that's why always use true or false. Okay, so if you still use numbers like 0, don't use it. Okay, okay, other questions?
If we initialize the values here, why
Mhm.
do we need the default constructor also?
So in that case, you don't need the default constructor. And if you remember, I'm all against the default constructor, right? If you remember the courses, I repeated this many, many times that the default constructor is bad. And in order to answer your question, you need, so in this case, if you initialize the attributes here, and if you still need the default constructor, you need it for two reasons. One is, remember that if we define a constructor here with any parameter, you don't have the default one. So if you still need it, you need to write it because now you don't have it. Remember, if you have at least one constructor, you don't get the default one for free. So this will be one reason. Maybe you still need it. So then you need to write it explicitly. And the second reason is that maybe you want to do something, to write some code in order to initialize any of these attributes differently. Okay, not with 0 and null. Maybe, for example, you want to initialize this one with some predefined values. Okay, so initially this is null, but in the default constructor, you say, yeah, for anything else, all the default values are okay. But for this one, I want to allocate it with some defaults. Okay, so this could be two reasons to have the default constructor. But defining here the default values, okay, like you see here in C++, this is mandatory. Because remember in Visual Studio and with your working with Microsoft Compiler, here you don't get null, and here you don't get null, and here you don't get 0. Here you get that 0xCCC. Okay, so those are two reasons why you should later define the default constructor if you need it. Okay, but always do this. So the alternative, what you are asking, just to make sure I got the question, is not initialize them here, right? And do
Yeah,
this here.
exactly.
Okay, very good question, because it happened to me many times and it will happen to you in the future. What happens if you have, so let's say we do this, okay? We do like you say, we don't initialize them here. Then I have a default constructor where I do all this stuff, which is a good thing because then it's needed. But now let's continue the story. What happens if you start doing this? You define different constructors with different combinations of values, value 2, and so on. So you have, let's say, 3, 4 constructors, and maybe you realize each day, each week, you need another constructor with another combination. What bad thing could happen? One probability will be this. When you define this constructor, you will focus on these two values. So here, you will initialize with a high probability only the attributes which are related to these two values, right? But what is the probability that when you do this, maybe not now, maybe next week, next month, when you define another one, another constructor, to actually forget, because you see there are many, to forget to set null or to set 0 on one of these attributes which is not directly changed here? Do you consider that this can be a risk? So for example, here you get the name, here you get the number of students. Okay, obviously here you will focus on these two variables. Do you think there is a chance that when you do that next month, you will forget to make this ID 0 and actually to do this for all? Right? Because this is what you do, right? You say ID 0, then you actually copy all of them. Let's clarify for the others why there are two correct answers. So what I was saying is that, you see, every time you define a new constructor, if you don't initialize them here, okay, you need to do this in each constructor, right? You need to do this copy paste and then to change only those values which are received here. And again, you see, this doesn't look okay. You have this redundancy, and there is a chance you will forget by mistake here because you get bored on doing this every time. You forget to initialize this one. And because it's not initialized here, it will be 0xCCC. So this is one perspective, okay? Here we are talking about how to code generally. Now, in the perspective of the exam, where you will have only one constructor to implement, yeah, if you don't initialize them here, but you need to be mature and assume this. Even if the constructor will not crash, because you do the right stuff here. For example, you have this constructor. I will take a constructor which makes sense. But if later your program crashes because you forgot to do this here and you didn't initialize it also in the constructor, in that one or two constructors that you will write, then yeah, you can say it's bad luck. I will say it's not bad luck. It's the what
Yeah,
you've
bad habit.
exactly. Yeah, thank you. That's a good completion. It's bad habit, exactly. But then, yeah, it will bite you back. Okay, and please don't blame me. So that's why generally what I'm telling you is to do something, even if it looks, let's say, not needed. Yeah, I agree with you. That might not happen. Your program can run for all the requirements perfectly because maybe you don't use these average tags ever. Again, if you want to reduce any possible risk, which in the end might make you lose time in order to figure it out what's wrong, then my recommendation is to do this. But that's why I'm saying it's a recommendation, okay? Because your program can also work without it. But thanks for the question, okay? So yeah, we are both right, let's say. Okay, other questions? Okay, so let's move to the next point. So let's define a constructor. And generally, when you define a constructor, and you will see everybody will need to implement a constructor, okay, other than the default one. So generally, I will ask for some parameters, not all. Why not all? Because maybe you have something like this. We don't have time to waste time for that. But generally, I will ask you to pass values for the dynamic ones, because in this way, we can easily test the class in main, because you can easily create a faculty and we know you will have values for the dynamic field, and then we can show them, and you can show and you can test easily that you know how to work with dynamic memory. Okay, so mandatory, you will be required to pass values for the dynamic fields. Okay, so let's write this constructor. So let's say you get all these three, which is not the case, but here I will just exemplify with all. So you need a value for name. Okay, I showed you also last year, we have seen that during the semester. If you want to be able, and I will show you in a minute. So here, let's say I'm using name. Okay, remember about shadowing. And again, sometimes I see this as a common mistake. Remember shadowing, which means if you don't use this and you say name equals name, this is, you see the color, they are both gray. So this is this one, and this is this one, which means the same variable equals itself. So that's why I'm always writing this. And I hope you have seen this is an issue also in Java and C#. Okay, shadowing and doing this mistake. Okay, now remember this is a char asterisk. We don't do this. This is shallow copy. But so here I'm saying char asterisk name. Now here I need the bachelor's program. So here I will say string asterisk programs. Let's use another name. Remember, when you get the pointer to an array like this one or like this one, you always need this, because otherwise, how do you know how many programs you have here? How do you know how many to copy, right? So every time you get a dynamic array of a strings or of a numbers or anything else other than chars, you need to know how many values you have in the array. So you can't otherwise. There is no function, magic function, which will tell you how many values you have here without this. Okay, you can guess, but not actually know. So here I need also the number of programs. So they go hand in hand. You can't have them without the other one. Okay, and the other one will be number of students. Number of students. Okay, and per year. Let's say per year. And here I need the second variable, which is number of years. Okay, let's split them to be fit in the same screen. Okay, so you need to know how to pass the value for the dynamic field. And I will come back to this one because this is not finished. And now, what else do you need to pass here? Remember constants. Okay, so remember that if you have a constant field, if you say this will be forever empty string and you can't change it. And if you say here equals 0, this will be forever 0. Okay, so that's why we don't initialize constants. Okay, so where I initialize constants and with what value? So let's say here I need address. Okay, I need the address. So how do I initialize? Remember the initialization list of the constructor? Okay, we talked about this. You have seen that in Java and C#, the syntax is more friendly. You can do this here in the first lines of the constructor, but again, not in C++. So here I need to say address of address. Okay, and if I pass value for country ID, okay, I need to do the same. And if you like this initialization list, you can do the same for other attributes, but not for pointers. Okay, don't fall in this trap. Okay, don't use this for pointers because they will do, this is equals, it will do shallow copy. Okay, so here I will say country ID. Okay, And always check the colors. Okay, I see this with gray, which is this one. I see this with black, which is this one. And you see, if you double click on it, the environment will tell you which one is. So if I double click this one, it highlights this one. Okay, so this is for constants. So if you have a constant in your class, I don't need to explicitly tell you, hey, you need a value for the constant. Okay, because you need it. Because otherwise, if you don't do this, you get a compiler error. Okay, so if I do this, okay, remember this compiler error, which says provides no initializer for const member faculty country ID. Okay, so in this case, I don't need to ask you to do this because it's mandatory. So if you have constants, you need to ask values for them and you need to initialize them like this. Okay, so let's say these are mandatory. Now, what else? What else? I don't know. Let's say number of students. So let's also ask the number of students, not per year, but the total. Or yeah, let's average tax. Let's ask for the average tax. Okay, so float average tax. Okay, so for average tax, remember, it's not mandatory, but you can do it here, or you can do it classically with inside the constructor using this. Okay, so everybody should be able to define this constructor, implement it correctly, and test it. Okay, so what do you need to do here? What do you need to do here is what we have talked yesterday evening. So here you need to copy the name. Here you need to copy the programs. Okay, and here you need to copy the students, number of students per year. Okay, so let me give you an example because it's easy. So remember, they are all dynamic fields. So you need to allocate space, right, before you do anything. Come on, just give me a blank line. Okay, so how do you copy the name? This name, new char, string length of name +1, and then string copy underscore s. This name, let's say maximum 100 characters. But no. That works for statics. So here I want to make sure it's this size and name. Okay, and yeah, let's do it also for the programs. I will not do it. We did that, but let's not waste this evening time with this. So this bachelor programs, new string, always allocate. Remember what we talked last evening. Always allocate if it's dynamic. And you see, this is where you need to write something here. Here, you need something like a number. Yeah, but how do you know there are 5 programs? So which variable tells you how many strings you need to allocate? This one here. That's why you need that one. And the same story for number of years because you need to allocate this one. Okay, and now for int I at 0, I less than number of programs. Okay, I plus plus, and then you say this bachelor programs, remember to index equals with programs at index I. Okay, and don't forget to initialize also your variable, because if this is not initialized, will remain 0. At least the program will not crash, but it will not print any bachelor programs because that's 0. So don't forget to initialize your number of programs with the number of programs. Okay, so, and then you do the same for students per year. Okay, so let's test this. That's why I had this discussion last evening, because I saw this many times. People now, they need to define some data to test this constructor. So what do you need to define? You need to define a name. Okay, so you have the CS string, Then you need to define some programs. And we have seen how this can be done. Okay, so I go for a static. Okay, and let's say informatics, cybernetics. Okay, then let's define, this is what we talked last evening. Number of programs equals to, what else? We need the number of students per year. Number of students per year. Let's say whatever, 450, 300. This is per year, so this is like 800, 700, 600. Okay. Okay, and now you know int number of years. Okay, 3. And now let's test the constructor. That's why I had this discussion last evening. Okay, because you see now you define some test data, and now you can test this one. So let's test it. So here I will say faculty here, and now let's pass the parameters. Okay, so now you see if I try to do this, okay, the IntelliSense does not help me. Okay, and now it's helping me, but let's see what I can use. And I see it. So I need to pass the name. So here is the name. Then I need to pass the programs. Then I need to pass the number of programs. Then I need to pass the number of students per year. Then the number of years. Okay. What else? Yeah, I lost it. Address, country ID, and average tax. Okay, address, let's say Romania, country ID 1, average tax, whatever, is like, I don't know, 5,000. Okay, so now let's split it. So here I'm testing the constructor. Okay, but let's say add an enum just to make sure we are here. So that will be what? Faculty type, faculty domain, right? And again, for the domain, I can use the initialization list, or here I can do this. Domain equals domain. And yes, here now, so let's switch back to programs. Here now I need the enum. And yes, for enum, you can say faculty domain economics. Okay, so regarding your question, I got another question, so let's answer also to that. Yes, for example, for a char array, you don't need to define an array here. You can use directly XIE. But the issue is with the others, because others, this is a string array, and this is a numbers array. So that's why you need the variables here to define the arrays first, and then to use them here, because you can't define them and use them here on the same line. But for the first one, yes, you can switch, you can skip the name, okay? But for this other two, you can't. Okay, so let's see what error we have. And here I'm going back to what I said earlier when I have defined the constructor. Remember for char asterisk. You see it, when you test it like this, so you either use name or you either use XIE directly, the error is the same. It's saying, let's zoom on it. 1 second. Okay, it's saying that, sorry, go back. Okay, it's saying local variable char name 5, and now it's saying the error. Now I have another error, so let's fix this one. It's saying faculty blah 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 declared line 38 is inaccessible, and I think this is an easy error for all of you. So what it means that by default, the entire class is private, including the constructor. So this is an easy fix. Okay, I forgot to put the public specifier here. Let's save it. And now it's the error is gone. But again, here I'm on a different laptop because my normal one crashed. And here I'm using Visual Studio 2019. So here, this is like going back in time 4 years. And 4 years ago, this worked. So if you are now on Visual Studio 2022, now you have a compiler error here. This is what I told you also in the course, that different versions of Visual Studio have different errors because they have different compilers. And that's why I ask you, hey, let's be all on the latest version, because this is what we have in the faculty, 22. So here in Visual Studio 2022, you have another compiler error saying that there is no constructor faculty which expects here a constant pointer to a char. Why? Remember, this is also what we discussed yesterday. Every time you define something like this, or you say like this is managed by a constant pointer. And the compiler, okay, yeah, you see, I replicated by writing directly XIE, but in Visual Studio 2022, you have also if you use name, it's the same error. You see, this is what you get. No instance of the constructor matches the argument list. So if in order to allow you to do this, this is a constant pointer. What you need to do, and remember we had this rule, and I said to you, every time you expect a char asterisk, always say const here. Okay? So every time you expect in a function parameter pointer to a char, always put this const, because this will allow you to also use predefined strings like we have now. But again, in Visual Studio 2022, you get the same error also for name. Here I'm on Visual Studio 2019. And back then they allowed this, and then they realized, hey, we need to force the developers to change that. So that's why in the latest version, the rule is more strict. Okay, so remember this. Every time you have a char asterisk, always pass a const as a const pointer to a char. Okay, because otherwise will not work for CA or name. Now, in terms of initialization, there is one variable which still need to be initialized, and you know it's special, so it's strange. Max students. Okay, so remember for max students, you can't do this. You get an error. Okay, so the only way to initialize statics in C++, again, you didn't have this issue in Java or C# where you initialize them there, is to do this. Redefine the variable, but you say, hey, this is the variable from faculty. Okay, max students equals 1000. Okay, so don't forget how to initialize your static variables. Okay, which you need to do outside the class to use this syntax. Okay, there is no other way, sorry. So this is something you need to memorize and specific to C++. Okay, so let's see what warning. The enum. Yeah, you see it saying that I should use the enum as class. But again, it's a warning. You can ignore it. Okay, so this is how you define the constructor with parameters. And now you can define different combinations. Watch out for constants. Watch out for dynamic fields. And remember, for any array other than a char asterisk, you need also to pass the number of elements, because otherwise you can't know how many there are. And remember that for char asterisk, you need to also to define it as a const. So use this rule for any other method, including the constructors. So now you can define any other constructors, okay, or the default one or whatever. Okay, so other constructors with other combinations of values. Now, regarding your colleague question from earlier, so if I do the default constructor now, why should I do it? So again, there are two reasons at this point. Remember that if you define a constructor in your class, you don't get the default one for free. So let's suppose here you need it. Like you want to create a default faculty management, okay? And you see is undefined. So this is a reason, despite the fact we have initialized them here, this is a reason to have the default constructor because you need it. But you know, I'm not such a big fan of the default constructor, so that's why I don't define them and don't insist on them. But let's say if you need it, you define it. So what can you do now in the default constructor? Obviously, if you don't want to change these values, just leave them, okay? Don't write those instructions again. But being a constructor, you see, you need to handle this too, okay? So in this case, you can say address, let's say Bucharest or Romania. So you put by default Romania, and country ID, yeah, 0. I don't have any other clue. Okay, so even if you write the default constructor, because we have two constants, you still need to put values in them, because otherwise you have that compiler error saying this constructor does not handle those constants. Okay, so this would be how the default constructor will look for this class. Okay, and the reason is that maybe I need it here to do that, to test something. Okay, so this will be a reason to still have the default constructor, even if we have default values here. Okay, so we have seen how to define different attributes. We have seen how to define the constructor. Now let's handle the copy constructor, which is mandatory. So if you have a dynamic field in your class, you instantly create the context for some memory issues, like dangling pointers, shallow copy, blah, blah, blah. So that's why if you have at least one dynamic field, providing the copy constructor is mandatory. What do you need to say here? Remember, this is the official way of writing it. So you say const faculty reference. Why reference? Because remember, the copy constructor is executed every time a function receives an object by value, every time a function returns an object by value, or when you try to copy something. So when you say this, faculty CA copy equal CA, okay? So here we are calling the copy constructor when you define and initialize in the same time, copy constructor. Okay, so these are the three cases when you need a copy constructor. This is one, and the second is when you have a function which receives an object by value, which means without this, and when you have a function returning an object by value. Okay, so that's why here I gave you the long story at the course. Why do you put the reference? Because otherwise this copy constructor will call itself infinite time. You have infinite recursion, you have Stack Overflow. Okay, so faculty. Now, why do you put this const here, and why do I recommend you to put it here? Despite the fact it's not necessary, you can also write it like this, but I recommend you to put the const because, again, people, some, not you, tend to forget which is the source and which is the destination. And they start doing this mistake. Faculty dot average tax equals this average tax. But this is wrong because this is the source. So this parameter is the value, this one is XIE. You want to take values from XIE and put them here, not vice versa. Okay, so that's why you put the const, because now you see you have this error. Expression must be a modifiable left value, which means this is constant because of this. If you don't put this const, the compiler will say nothing, and now you do the mistake. And then you will lose minutes, a lot of them, figuring out why this doesn't work. Okay, and then I will see you staring at the monitor and I will tell you, hey, you have a mistake in the copy constructor. Check which variable is which. Okay, so, but you lose a lot of time. Now you see instantly that's wrong, and maybe if you ask yourself why that's wrong, maybe you remember this discussion or the discussion we had during the course. Okay, so then you say, sorry, this is the right way. Okay, now, because this is a constructor, it's a copy constructor, but it's still a constructor. Again, you have the issues with these ones. Okay, this will haunt you for the rest of the program, the constants. Okay, anytime you define a constructor, they are there. So what do you need to do? You need to copy them if you want, but you can. So here I will say country ID. You need to write something here, okay? You can't just ignore it. Country ID of faculty dot country ID, and the other one was the address, faculty address. Okay, so because you have the constants. Okay, and then copy the others, other fields, including the dynamic ones. Okay, so this is the issue with the copy constructor. Okay, this is what I wanted to highlight. Watch out for this here, and actually watch out for this mistake. Okay, and again, if you have constants, remember you need to copy them because you can. Okay, remember for equals operator, you can't copy them. Okay, so for equals, it's a different story because here you are creating a new faculty. So it's okay to initialize the constants. When you use equals, or when you overload equals, which we will cover tomorrow, you can't copy them because the object already has a country ID and an address. And being a constant, you can't change it. Okay, that's why for equals, you can't copy them. This is the reason. Okay, so this is the copy constructor. And it's important here to copy the other fields properly, like we have discussed yesterday. Okay, so the last special method, remember, is this one, is the destructor. And basically in the destructor, we just deallocate, which means we just do this. Name. So we deallocate all the address, so not address, was the name, bachelor programs and numbers. So bachelor programs, okay, and delete this number of students per year. Okay, and again, why is it important to put defaults here? Because if you have null here, this will do nothing. But let's say you forget to put null for this one, and here in the constructor, you forget to initialize it. Maybe you forget to initialize it. What will happen? This will crash here because this will be 0xccc and you can't delete that address. Okay, so again, this is another reason why I'm asking you, not recommending you, for your benefits. I'm asking you to put, especially for pointers, null, despite the fact that you initialize them here. Maybe you forget, and then it will crash here, and you wonder why it crashes here, and you lose time. Okay, when the issue is that the issue is actually here. You forgot to put null here, and then you forgot to initialize it here. Okay, so it's not the destructor, let's say, fault. Okay, so this is the destructor. Okay, generally everybody, I don't see any, don't remember anyone doing, I don't know, mistakes in the destructor. Now, what's the catch with the destructor is how you test it. And I showed you how to. Let's do this again. So how do you test the destructor? Okay. Okay, which you can't because management, it's a faculty, so it's not a pointer. Or I saw this. How do you test it? Okay, so for example, if I put a breakpoint here and stop your program, at this point, you will see no message like, hey, it works. So why do you see the messages sometimes? Because remember, when you define a main has a stack, right? So faculty constructor, the destructor, sorry, the destructor. Okay, so because main is a function and it has a stack, all right, let's run this program and see. So Control F5. Okay, so let me share the console. You see, it's working. faculty destructor, and we did nothing, right? Which means we tested it. Yeah, we did something, but it's not something we wanted to do at that moment. This happens naturally. Why? Because, again, where is my Visual Studio? Okay, main, it's a function. It has a stack. So every time you define a variable, that variable is on the function stack. So what variables do we have on the function stack? We have this pointer, actually it's a static array. We have this static array, we have this static array, we have this variable, and what's this? We have this variable. What's this variable? It's a faculty. Next, we have this variable. What's this? Another faculty. What's this? Another variable, a faculty. So how many objects do we have on the main stack? 3. 1, 2, 3. What happens here when main finishes? The stack is destroyed, which means all the variables on its stack are destroyed, like any other function. So how many objects do we have on the stack? 3. How many objects needs to be destroyed? 3. By whom? By this. So how many messages have we seen? 3. Okay. So now every time you do something with objects, you will see more or less of this message, right? Because new objects will be created, some objects will be destroyed, and so on. But how do I test it? So what I told you, how do you test it? Remember, objects, they have a scope, like variables, which means a variable is visible in a context, like a function. And once the variable is out of scope, it needs to be destroyed. So how do you create a scope? You open brackets. This is like an anonymous function. So you open these brackets, and here I'm saying faculty accounting. And let's put a message here. The end. So what do we have here? We have a context, a scope, and inside the scope, we have a variable, which means when the program enters here, we'll create this variable, which is a faculty. But when the program exits these brackets, this scope, what happens with the scope? This is destroyed, which means here, this will be destroyed. So we will see the faculty destructor message before this one. And then we see the other 3. Let's see if this happens. So build, rebuild. Okay, so Control F5. Let's show you the command prompt. You see it? So this is accounting, which is in that scope, in that temporary block, and then you see the end. Okay, so now I have control on that object lifecycle, which means I create it and I'm destroying it because I use it only in that scope. Okay, so this is one way to test the destructor and not wait for the last message and, I don't know, play it by chance. So this is one way to test the destructor. Now, what's the other way? How can we create objects and delete them when we want? Where do we need to do that? In heap. In heap, I can do that easily. So what do? I create a pointer to a faculty, and I say new faculty. So what I have done now, I have created an object, a faculty object, not on the main stack, but in heap, which means I have control on its life cycle, which means I can delete it instantly. So what happens here? We ask for this object to be removed from heap. Who's executed for that? The destructor. So here again, I have control over the destructor because I'm implicitly asking for it by deleting the address here, the object here. So if I run this program, now I will see 2 faculty destructor messages before the end message. You see them? So this is from the scope example, and this is from the heap. So choose your own way. And because the destructor is mandatory, So Destructor is a mandatory requirement for the exam because you have a dynamic field, that's why. Testing it is mandatory. So choose which version do you want, okay? So in this way, you test the Destructor. And here, in order to avoid creating a dangling pointer, just say null pointer, okay? After you delete it. Okay, so here we have covered the, let's say the issues, the special issues with the special methods. Constructor, copy constructor, destructor, and so on. Okay. So if you have any questions on this topic, okay. So we covered the like I said, this will be we cover it when we talk tomorrow about operators because it's an operator. Okay. So if you have any questions regarding constructor, destructor, copy constructor, let's see. Marks tax. Again, how do we initialize it? In the same way, but now it's a float. Float faculty max tax equals, I don't know, 9,000.0. Okay, so this is a float, a double the same way. A string. We can have a string like default country. Okay, so how do you initialize it? String faculty default country. Okay, so they all behave in the same way. For example, if you have here a static which depends where the value is something that depends on what you do here, maybe then like this. This is a classic example, but don't expect this one, but just to get the idea. Let's say a number of faculties. So you have this static, and let's say here you want to count how many faculties you have created. But again, you initialize it in the same way, right? So you have the number of faculties, 0, but now is how you use it. For example, the max tax, I'm using it in order to validate the average tax. If I do a setter, I validate not to exceed the max tax, right? But how do I use number of faculties? For example, when I'm creating a faculty, here I will increment that. So here I will say faculty, number of faculties plus equal 1. Okay, but this is how you use it. Okay, so they are all initialized in the same way, but some statics have a different utility. For example, this one, I'm using it to count how many faculties I have created in the system. Okay, and for max tax, I will use it in the setter to validate the average tax. Okay, but how you initialize them, you see, is in the same way. Okay, so what are the issues with the public interface? Okay, so what can go wrong? Okay, so let's we were talking about that static, so let's do a setter for average tax. Okay, so let's say public interface. So if I do a setter for set average tax, then, setters need a value, so float value, and generally I will ask you to validate and throw an error. We talked we had a course on try-catch, and I explained you why it's better to throw exceptions, and maybe you use those exceptions at C# and Java to notify other controls and modules. Okay, so here I will do this. If value is less or equal than 0, let's say the tax can't be 0, and now I'm using the static. We were talking about it. And if value is bigger than faculty max tax, so you see here the max tax has utility as a validation value, then remember we are using throw, and again, so here you just can say throw value invalid, whatever. Okay, so you don't need to define here at this point a custom exception. Okay. Okay, so this is if, and if I pass if, then I have this average tax equals value. Okay, so this will be the setter for a float value. And to finish the discussion, let's also define a get value, get average tax, sorry, get average tax. Okay, so here I'll just return this average tax. Okay, so, and this is float. So this will be a standard setter and getter, which also validates in throw an exception. Okay. So what can go wrong with setters and getters? Obviously, I don't see any reason for something to go wrong here, but if you implement a getter and a setter for a dynamic field, remember we had a discussion on this, and I said to you, this is not okay. And I showed you how a hacker or another colleague can change your values. So for setters and getters, always watch out for the dynamic fields. Okay, so don't do this. Okay, so if I want to define for example, a getter for the name, okay, because it's a dynamic field, don't do this. If I see you do this, I will tell you, hey, that's wrong. Remember what we have discussed during the course, that is not okay to return me the address of the pointer. Please return a copy. Okay, so I will give you a hint why it's not wrong. Okay, so if you do this get name and you just say return this name, now you give me the pointer. And why is this is not okay? Because now I can delete your name. I can change your name. I showed you that. So that's why don't return the pointer directly. So what you need to do is return a copy. Remember, this is the rule for all dynamic fields. Okay, so here you will say char asterisk get name. And now you know how to create copies for any dynamic field. So in this case, I will just say char asterisk copy equals new char of string length of this name plus 1. Okay, now if name is null, this will crash. Here you get null pointer exception. So if you want to avoid that, always test your name. Or let's say if it's null pointer, then you return. Okay, it's simpler like this. Because it will crash on a string length. So this cannot get a null here. That's why it will crash, and that's why you need to do this test. Okay, but if everything is okay, now you can say copy string copy underscore s. Okay, copy this size from here, and you take the values from name. Okay, and then you return the values, the copy. Okay, so this is something you need to do for all your dynamic fields. Okay, so if you implement a getter and a setter, always return a copy. That was an issue we have covered extensively during the course. And for setters, now for setters, always do copy, but there is a difference. And let's see another wrong way to do this. So set name, char asterisk new name. Again, here you can put const, and remember for char asterisk always put const, because maybe then you try to change with management as a string. So remember the rule that we also saw earlier. So this is bad. Okay, no, not okay. Don't do shallow copy. Again, something we discussed, and you have this issue also in Java and C# with shallow copy. So don't do this. A lot of issues will come from this. And here we have a compiler error. Fortunately, we have this, because now the compiler is not allowing you to do this. So what do you need to do here? Again, you need to copy it. Okay, so let's take the code from here. Okay, so don't do shallow copy. Let's put the comment here. Don't do shallow copy. And this goes for all the other dynamic fields. Don't use equals. Okay, new name. Okay, and because when you call set, there is a chance you already have a name. What you should not also do, don't create memory leaks. Now, the program will not crash if you forget this, but again, I will tell you that the setter is not fully right, and you have forgot to do something. So if this name different than null pointer, delete it. Okay, so you want to make sure you don't create memory leaks. Okay, so this is let's say what you need to watch out for, getter and setters for dynamic fields. And this is specific to dynamic fields like const char asterisk. But remember that if you have a setter for the other types of dynamic fields like programs, which is not a char asterisk, it's a, let's use const or not. It's a dynamic array of strings, new programs. Okay, remember that you always need a second variable, because you don't have string length. You don't have a string length like you have it here for char asterisk in order to determine how much space do you need. And you see, you know what's the common error? Maybe you did this at the laboratory test, but let's see it once again, and let's hope I don't see it and you don't write this next week. This is the common error I see people is doing. So they do this. They know they need to allocate, and they know they need to avoid memory leaks. So this is what they do. If these programs, bachelor programs, different than null pointer, they do this, delete, and they say these bachelor programs. Okay, which is okay. So you do this to avoid the memory leak. And now this is the $1 million moment. They say this bachelor programs equals new string of, and there is this moment when you know you need to write something here, and the only variable you have at this point in order to use is what? This number of programs. 1 second. Yeah, number of programs. Okay. And now, and then they copy. Why this is wrong? This is where this setter is wrong because of this. Why? Let's imagine you have a faculty like CM, which has 3 programs, 2, informatics and cybernetics, okay? And now you create a new array of programs, okay? So let's say I'm creating a new array of new programs. And let's say we add statistics. Okay, and now you call the setter. So CA set programs of new programs. How many programs do you have in new programs? 3. How many programs you had in CA? 2. So what's the value you have here in number of programs when you call the setter? It's 2. Why? Because this is the value you had from the previous array, from the previous context, when you had only informatics and cybernetics. So how do you know when you call this setter how many programs you actually have here, because this is what you want to copy. Do you have any clue? No. Why? Because no one here tells you that value. So please don't do this mistake. We talked about this during the course, and the conclusion was what? Every time you write a setter for, or not a setter, any method, anytime you write a method where you want to give a value for one of these dynamic fields, like bachelor programs, like this one, like we did in the constructor, you need to give me two variables. You need two variables. You need the values, like the array itself, and then you need the number, okay? Because you can't make it work with only one. You can't. So it's only guessing, but that doesn't work. So number of new programs. You need this variable because you need this variable here, okay? You need it here, and then now you can copy number of new I++, and now you copy them. Bachelor programs index I equals with new programs index I, and then after you copy, don't forget this again, this is important. This number of programs equals new number of new programs. Okay, so this is the way you write setters for dynamic arrays where you need the extra variable. Okay, so this is a common error that I saw recently. People forget to pass this variable, and they reach this point where they realize they need a variable, but instead of realizing that they forgot to pass the variable here, they use this one from the object here, but that's not okay. It might work if you have a bigger number here in number of programs or less, but at some point it will crash. Okay, so these are the, let's say, the vulnerable points for setters and getters. Okay, so these are the places where I saw mistakes. And again, this is the part where you need to implement right without issues. Okay, now other than that, for any other variable, you just do it like for average tax. Okay, so just validate. Obviously, we should also validate here, but let's say we simplified. If you understood the power of const, so if you understood that you have only benefits of having this const here because will prevent you for doing this mistake, new programs equals new string of whatever. Okay, so now on Visual Studio on your version, you'll get a compiler error here because now this is const. Then yes, please use it. Okay, so I will not complain, I will be happy. But if this is not clear, it's like, okay, so when do I use it, when I don't use it, then stick to the simpler rule. Okay, at least use it for char asterisks. Okay, and because of that, that's why I write the code sticking to these rules. But again, it's a preference. So let's agree with that. That const is optional. And now the next question: why would sometimes we write const, or why do I say it's better to always write const, even if I don't do it, okay, all the time? So what this const does here, and what this const does here, and what this const does here and here is the same. So every time you see a const here in the list of parameters, and you see this const for a string pointer, and you see it for an int, or you see it for a char asterisk, or you see it for a reference, it doesn't matter to what the reference, const has the same meaning. It means that the variable which has this type, in this case a reference, in this case a pointer to a string, in this case an int, and so on, is constant, which means you are not allowed to change it inside the function. That's it. And let's validate this. When you write a function like set programs, in logically, do you have any reason to change new programs and number of new programs? Do we have any reason to change them? No.
No.
Exactly. So why would I write const? Because despite the fact we have no reason to change it, we are humans, and sometimes we do mistakes. We do this. So how can I prevent me, despite the fact that logically I said there is no reason to change number of new programs, to block me to do this? This const. Because you see, now I have the compiler error. Expression must be a modifier left value. Without the const, I can do it. So now I do a mistake and no one alerts me. Because from the compiler perspective, if I want to change this variable, I can change it. And we know this has no effect, right? Because if you change it inside the function, you don't change the variable outside because it's by value. So again, another reason why are you trying to change it? Okay, so this is the value of const. Remember, every time you write a const, the variable with that type becomes a constant variable, which means you can't change it. Why would you do that? To protect you from you. To do this, and this is a nasty bug, because this will not crash your program, but you will lose a lot of time figuring out why it's not working. Okay?
Basically, we're using const for us what it's supposed to do, to not change a value.
Exactly.
If we don't use it, I mean, if we have it and we don't use it to change the value, there's no reason why we wouldn't use const and so on and so forth.
Exactly.
Yeah, I see. Thank you.
And at this point, maybe you see, it's a nice thing. It's optional. You know, you put it there. Maybe I will use it. Maybe I will not use it. But if you follow this path as a software developer, and if you will have sleepless nights, wasting hours for something you will say, I will do that in half an hour. And then you lose hours, try to figure it out what's wrong. And then you realize, why did I change this variable here? Why did I not change this one? Then you will have all these painful moments. And then you will say, that's not optional. I don't want to go through all that pain. Why we don't do this? Let me give you the explanation. And this is the same reason for all the other arrays. Let me show you. So you have a name, right? It's for xie. It's xie, right?
Yeah.
It's in heap, it's allocated, it's yours. So you are xie as an object, and you have this string, it's yours. And we have allocated here in the constructor. Let me show here. So it's yours. And now let's suppose so let's comment this one. We can't have both. Yeah, let's say get name wrong version. Wrong version. Okay, so now let's call this one. Let me show you what I will do. And I think you'll get the idea. So here you see I have now this error because I need to pass the number of values. Okay, so test getter. So now I do this char asterisk your name equals with xie dot get name wrong version. And now let's think. What do you do here in get name wrong version? You say return this name. So are you giving me now the xie string or its address from heap? What do you give me?
Definitely its address.
Exactly. So if you give me the address, can you stop me do this? What's your name now? It's xie? No, it's xie.
Yeah.
And what happens if I do this? Delete your name. Do you have a xie anymore in heap? No. But you still have the address, right? So what do you have? You have a dangling pointer. what will happen when this program terminates and the destructor tries to delete the name? Can you delete dangling pointer? No, it will crash. Because you still have the address here of XIE. You have no idea that someone just deleted your name. That's a dangling pointer. And when you try to delete it, it will crash. You see? This is the
But
danger of giving me the address of any pointer. I can do anything with that address.
but why do we still have the address in this case?
Because you have two variables. One variable is here.
Right.
And where is the other variable which stores the XIE string? It's inside the XIE object. And here it is. Is this one.
Yeah.
So how many variables at that point are pointing to the string XIE and heap? Two. One, which is this one here. And one, which is not visible here, but we know it's inside this object and it's called name. So now you have two variables, different variables. When you change a variable, for example, when you have this int VB1 equals 10, and then you say int VB2 equals 10. When you say VB1 equals 100, in any language, is anyone letting know VB1, VB2 that VB1 change its value? Are they synchronized? No. Right? There are two different variables with which at this particular moment in time, they shared the value, but they are different variables, which means later I can change the value of VB1, but VB2 it's still 10.
Yeah, because we don't have pointers to point to.
Exactly. So if you ignore the fact that this is a pointer and we focus on the fact that this is a variable, is this a variable? Your name? Yeah, just ignore it's a pointer. It's a variable, right?
Yeah.
Is this name a variable? Yes, it's a variable. So they have a value, which is a number. Just ignore it's an address. It's a number. When you say your name equals get name wrong version, what do you get? You get the value of the variable name inside XIE, right? So now you have two different variables. One is name here, and the other one is your name here, which share the same value, which is an address. And then you delete that address in heap. Is any rule saying that if you delete a pointer, someone from the operating system will go through memory and say, hey, stop. There is another variable here in XIE, which is name, which shares that same address. Let's notify it. Let's call it and say, hey, you know that address? Someone just deleted it. Is this happening? No. So when you have something in heap, you have two things. You have the value, which is stored in heap at that address. And for us is what? XIE as a string, as ASCII codes, right? You have this text.
Yeah.
So this is the value in heap. And the other thing is the address of this thing in heap.
Yeah.
So every time you have something in heap, you have two things. You have the value itself, which could be an array of values or a text. And then you have the address. Now, pointers, what they handle? What's from these two values, what is a pointer handling? The value itself, like exactly the address. So you have this duality. You have the value in heap and you have its address. So now you have this pointer which gets the same address as the name pointer from XIE. And when you delete, you don't delete the value from the pointers. It's like you say to heap, hey, you know I have something at this address, a text XIE and heap. I don't need it anymore. Just remove it. But the pointer, this pointer and the pointer name inside XIE, they still have the address. Because when you delete something, the pointer is not changed. The pointer is not like saying, you deleted my address, let's take null. No, the pointer still has that address. And the pointer has no issue that has no idea that at that address, there is nothing more there. That's why it's called a dangling pointer. A dangling pointer is like a stupid pointer. It has an address, but it has no idea that there is nothing there.
Yeah.
So how do you delete, how you avoid the dangling pointer? You need to make it null. But at this point, you make only this pointer null. But what about the one from inside XIE, name? Is anyone putting that to null? No. When you do this, no. So what you actually need to do here in order to fix this, because is this the mistake? No. Where is the mistake? Actually here, because you did this. So what are we trying to do here? To patch it up? But this doesn't work, okay? At some point it will still break. So how do you patch it up? Let's say you don't want to fix this, but you still want to fix it, the story itself. What do you need to do? XIE name equals null pointer. But you, sorry, not get name, name. This is what you need to do here. But can you do this? No, because this is private encapsulation. And then you say, yeah, but let's call set name with null. Yeah, but I'm pretty sure in set name, you check for null, right? Because you don't accept null. It makes no sense. So you see, at this point, you actually can't fix it. You can't say to this one, hey, lose that address. It's wrong. You're a dangling pointer. So how do we avoid all these issues? Like I can change your name, I can delete your name, I can create a dangling pointer for you and you don't know and the program will crash. How do we avoid this? Why are we here? Because of this. Because we just returned the pointer. This is the reason for all that. So how do you remove the root of all those issues? Just give me a copy. Why? Because if you give me a copy, what's different? So instead of saying your name equals get name wrong version, if how is different if now I call the right version, get name? What is different? Remember now this returns a copy. So if I do your name 0x, do I now change your name? And by you, I mean XIE as a faculty. Do I change now your name? No, this is a copy, right? I change my name, which is a copy. So XIE name is still XIE. If I delete this pointer, do I also delete XIE in heap? No, I delete my copy because this one receives a new address, which we return here. That's why we return a copy. You see, I'm creating a new array in heap with the same value, but it's a different address. So name now it's safe. Okay, so no dangling pointers. I don't need to do this. Yeah, thanks. Remember, I also do mistakes, the same mistakes as you. The only difference is that I did this many, many times, so I will fix it faster than you. But in the end, I do the same. Thanks. Yeah, you're right. So I was copying from myself, which was nothing, and that will crash. Thanks. Okay, other questions, issues regarding setters? Okay, so don't do shallow copy. Don't take the address directly. Okay, always return a copy. Okay, don't do the shallow copy here. And for the other types of arrays, always ask for the second parameter. Okay, because otherwise you don't know how many values you need. And if you are still asking, yeah, but why for the char asterisk we don't ask here for number of letters? Why we don't do this? Because you have string length, but this works only for strings. Okay, so that's why here you don't have a second parameter, because for strings, for char arrays, you can count. Okay, so you can determine that number on your own. So that's why you don't need the second parameter. And because here you don't have other functions like this. Now you have seen in Java and C#, you don't need the second parameter, right? Because in Java, all arrays like this one are actually array objects and they have size or length the same in C#, right? So in those languages, you are actually working with objects, even when you are using arrays. So that's why in Java and C# you don't need a second variable, because this is actually an object. But now we are here in C++ and we don't do that. So this was the idea about, let's say, the important stuff regarding setters and getters. Okay, now the only thing here to other methods is how you process this stuff. So defining a method, it's simple. I didn't see any reason here, like whatever, do something. Okay, the only thing is, remember, you can have static methods. Okay, and the difference, and this is what I want to highlight, or for example, do something, and here I can say return this, because all these class member functions receive the pointer to the object, because in order to call do something, you need to use an object. So here I can say average tax. Let's say everybody talks about increasing taxes all over the place. So let's say we double the tax. Okay, so you have access to this. Why? Because here you will say xie do something. So you need an object. Okay. Now, if you define a static method, like static whatever, print message, okay, and this returns a void. Remember these static functions, but again, I think now it's more clear to you than it was when we did this, because you have the same rule in Java and C#, and I'm pretty sure you play with static functions. And I think it's more clear now after going through the second semester, the difference between static, but nevertheless, I just want to make sure it's clear. So remember here, you don't have this, because in order to call a static method, you don't need an object. So there is no this, whatever, you see, it's giving me a compiler error. This may only be used inside a non-static member function. So generally here you do something without using an object, because you don't have the object. Okay, hello. So that's the difference. Okay, just remember, when you have a static method, it does not receive the object. So when you call it, you need to call it using the class specifier. And the same in Java and C#, but again here, instead of dot, you have two dots. Okay, so you have print message. Okay, so remember the difference between class member functions and static methods. But again, I'm pretty sure for most of you, this is already clear, because you had this discussion also in Java and C#. Okay, so with this, we covered all the, let's say, spots when things can go wrong and how you should do this properly in order to avoid all these moments. Okay, so I've just showed you all the possible issues that you can do wrong